Hello everyone. The next topic I am going to explain is Spearman's rank correlation coefficient. Spearman's rank correlation coefficient. Curl-Pearson method is based on the assumption that population being studied is normally distributed. Now Curl-Pearson is based on the assumption that population is being studied normally distributed. When the population is not normal, then this method, we cannot use this method. Then his method is not useful to find the coefficient correlation. That's why Spearman in 1904 has given ranks to the observations according to the size, and he based on that the calculations on ranks rather than original observations to avoid the assumptions about population defined by Curl-Pearson. Now this method is called rank correlation. It is denoted by capital R rho, symbol rho, capital R rho of xy. To define the quantitative characteristics, when we have to use this rank correlation, when we have to apply this rank correlation to define the qualitative characteristics example. To define the qualitative characteristics, example honesty, beauty. In terms of quantitative measure, this method is very useful. The formula is capital R is equal to R rho of xy is equal to, the formula is 1 minus 6 sigma di square by n into n square minus 1. This is the formula, where di is the difference between two ranks. Di is the difference between two ranks. This is the formula. Capital R is equal to R rho is equal to 1 minus 6 sigma di square by n into n square minus 1, where di is the difference between two ranks. If the ranks are repeated, if the ranks are distinct, we have to use this formula. If the ranks are repeated or equal ranks, if the ranks are repeated or equal ranks, then we have to use another formula. What is that another formula? R is equal to R rho of xy. Rho of xy is equal to 1 minus 6 into sigma di square plus m1 into m1 minus 1, m1 into m1 square minus 1 by 12 plus m2 into m2 square minus 1 by 12 plus m3 into m3 square minus 1 by 12 plus and so on, whole divided by n into n square minus 1. This is one more big formula, n into n square minus 1. Now when we have to use this formula, if the ranks are repeated or equal roots, two ranks are equal or three ranks are equal or two ranks are repeated or like that, we have to use. Where what is m1, m2 or mi, or mi, m1, m2 means what is m1, m2 stands for? Mi stands for the number of items whose ranks are common. While doing the problem, I'll tell you about this. If there is more than one group of items which is common rank, this value is added as many times as the number of such groups. Note, if sigma di is equal to 0, if the data is, what is the meaning of that? Sigma di is equal to 0. If the data is in the form of ranks, this method is useful. If n greater than 30, then it is cannot give the reliable value. For calculating correlation for quantitative data, this can be applicable, but slightly effective than coefficient of correlation, Curl-Pearson. Now we will see the first problem. See the first problem. Calculate the rank correlation coefficient to the following data. X data is given, a rank correlation coefficient to the following data. X data is given, x is equal to 60, 34, 40, 54, 57, 35, 36. Y data 70, 72, 65, 68, 64, 37, 42. Now the data is given like this. If the ranks are not given, this is some data is given, sometimes they will give you ranks, sometimes they will give you data. If the ranks are not given, we have to assign ranks for both the variables x and y, assuming rank 1 to the lowest value or highest value, that is here highest value is equal to rank 1, the next highest value rank 2, next highest rank 3, like that. Otherwise lowest value rank 1, next low, like that you can give, that is your wish, rank 1 to the lowest value or highest value. We have to follow the same method for both variables. Whatever you follow to the x variable, the same method you have to follow to the second variable. X data, y data is given. The out of x, the highest data is 60. That's why Rx. Rx means rank x 1. The next highest is 50. Next highest is 57, rank 2. Next highest is 54, 3. Rx means ranks. I am giving to the ranks to the x variables. First highest value I am taking as rank 1. The next highest is rank 2. 57 is second rank. 54 is third rank. 40 is fourth rank. Like that. 36 is the next fifth rank. Like that I have given Rx values. In the same way, observe the y data. The highest is rank 1. Highest, how much is highest here? 72, rank 1, Ry. 72, rank 1. The next highest, 70, rank 2. Next highest, 68, rank 3. 65, rank 4. 64, rank 5. Like that, Rx, Ry. Di, what is Di? Rx minus Ry, difference between two ranks. Di is equal to always Rx minus Ry. Rx minus Ry, like this you will get Di square. Di square, the whole square of this one. Sigma Di square. Sigma Di square means summation. Summation Di square is equal to 48. Here the ranks are not repeated. See, all the values, x values, y values are distinct, different. We won't get any repeated ranks or equal ranks. We did not get any equal ranks or repeated ranks because the complete data is distinct. Whenever the complete data is repeated or equal or some ranks are equal, then we have to use second formula. Here only we will use the first formula. The ranks are not repeated. Sigma xy is equal to 1 minus 6 sigma di square by n into n square minus 1. Di square is equal to 48. Number of observations. How many observations are there? N, small n. Number of observations is equal to 7. Now, if you substitute all the values in the formula, 1 by 7 is equal to 0.14. Spearman's rank correlation coefficient between x and y is equal to 0.14 is the answer. If the ranks are distinct, if the ranks are not repeated, then we have to use this formula. Like this you have to do. Now, if the repeated ranks, we will see. See the next one we will see. Calculate the rank correlation coefficient to the following data. X data, Y data. Complete X data is given like this, Y data is given like this. If you observe the X data, 75 repeated two times, 14 repeated 3 times. Like that, few values are repeated. Remember, you observe the data carefully, you can observe. Now 14 in Y repeated thrice, 75 repeated twice. That means the repeated data is given. That means you will get repeated ranks. Whenever the repeated values are equal values are there, we have to use the second formula. Now, by observing the given data, I am writing solution. In the given data, we have to assign the ranks. To the given data, we have to assign the ranks. But in the above series, there is more than one item with the same value. More than one item with the same value. In such cases, the same ranks are to be given to the repeated items. This same ranks is average of the ranks which these items would have assumed if they were different from one another. See X data, I will explain in detail. X data is given, ranks we will give. The highest data is rank 1, number 1. Next highest is 78, number 2. Now the third value, the next highest is 75, occurs 2 times. 75 occurs 2 times. Remember, highest is rank 1. Next highest is 78, rank 2, it's okay. The next highest is 75, but 75 is not distinct. 75 is repeated twice. 75 repeated twice. That means third rank, fourth rank. 1, 2 is over. Next third one, fourth one. 3 plus 4 divided by 2. 2 ranks we are adding, that's why divided by 2. Third rank. plus 4th rank divided by 2. 3 plus 4 divided by 2 is 7 by 2. 7 by 2 is 3.5, 3.5. The next rank is, the next highest is 68. 3rd, 4th is over. Next is 68, 5th rank. Next highest is 67, 6th rank. Next is 60, 7th rank. Next is 59, 8th rank. Like that. Now 75 occurs 2 times. That's why divided by 2. 3rd rank, 4th rank. 3rd place, 4th place. 3rd plus 3 plus 4 divided by 2 is 3.5, 3.5. The next one. Now y. If you observe the y datum, the highest value is 17, first rank. The next highest is 16, second rank. The next highest is 3, 15, third rank. The next highest is 14. But next highest 14, how many occurs? How many times? 1, 2, 3 times. 1, 2, 3 times. First rank, second rank, third rank is over. 1, 2, 3 ranks are over. 4th, 5th, 6th place. 4 plus 5 plus 6 divided by 3. 4 plus 5 plus 6 divided by 3 is 4 plus 5 plus 6 is 15 divided by 3. 15 divided by 3 is 5. That's why we have to write 5, 5, 5 for these 3. 5, 5, 5. Because 4th place, 5th place, 6th place. Repeated 14 is there. Repeated thrice. That's why 4 plus 5 plus 6 divided by 3 is equal to 5, 5, 5 we have got. The next highest is 13, 7th rank. 1, 2, 3, 4, 5, 6 over 7th rank. The next highest is 8, like that. After that, D is Rx, Di. Di is equal to Rx minus Ry. You will get like this. Di square is like this. Sigma Di square. Di square you have to calculate like this. Sigma Di square also you have to calculate. And after that, repeated ranks occur. That's why we have to use repeated ranks occur. We have to use the big formula, second formula. R, capital R is equal to 1 minus 6 into sigma Di square plus m1 into m1 square minus 1 by 2. m1 into m1 square minus 1 by 12 plus m2 into m2 square minus 1 by 12 whole divided by n into n square minus 1. Capital N, number of observations. How many observations are there? 8 observations are there. Number of observations, small n. N is equal to number of observations, n is equal to 8. Now sigma Di square is equal to 159.5 we have got. Now M1. What is M1 stands for? Now what is M1 stands for? In the first data, in the X data, 75 is repeated twice. That means M1 is equal to 2. Because 75 is repeated twice, only 2 times. That's why 75 is repeated twice. That's why M1 is equal to 2. Again repeated item is 14, 14, 14. Repeated how many times? 3 times. Repeated, that's why 14 is repeated in Y data. 14 is repeated thrice. That's why M2 is equal to 3. Why 3? It is repeated thrice. That's why M2 is equal to 3. M1 is equal to 2. M2 is equal to 3. Now M1, 2 into 2 square minus 1 by 12. M2, 3. Why 3? It is repeated thrice, 3 times. That's why M2 is equal to 3. Now 3 into 3 square minus 1 by 12 by n into n square minus 1. Simplify as simple as possible using the calculator. You will get minus 0.929. This is the answer. Like this you have to do. Thank you very much.